For decades, there have been only two ways for fighter jets and bombers to carry and launch air-fired missiles. Either the missiles were carried internally within a bomber's bomb bay, or lugged, that is, attached externally on pylons under the wings with lugs. These two methods have been, and continue to be, highly effective, limited only by the number of missiles a particular plane can carry during a single deployment, and the number of planes deployed in any given operation. Now, the US has turned that equation on its head. The Pentagon has come up with an ingenious new system that promises to greatly expand the number of aircraft capable of deploying cruise missiles and the number of missiles they can carry. The Rapid Dragon system. It looks like a game changer, especially in the Indo-Pacific theater, where the US has been actively seeking new ways of overwhelming and neutralizing Chinese air defenses. Even better, Rapid Dragon doesn't require any expensive new equipment to be built, or even any drastic modifications to existing tech. In fact, the idea makes so much sense, you wonder why no one has thought of it before. Here's what makes Rapid Dragon so unique, and how it could swing the balance of power in the Far East decisively in the US's favor. In 2023, the US Air Force's Research Laboratory defined Rapid Dragon as a palletized munitions experimentation campaign exploring feasibility and operational advantages of airdropping long-range palletized munitions from existing airlift platforms, such as the C-130 and C-17, without aircraft modifications. In layman's terms, Rapid Dragon converts cargo aircraft into weapons carriers that can deploy cruise missiles and potentially other standoff or self-defense weapons by releasing them on pallets via the plane's rear cargo ramps. In other words, it turns a cargo aircraft into a bomber whose weapons load is theoretically limited only by how many pallets will fit in the cargo bay. Now, cargo planes have been used to drop bombs on enemies since at least World War II. During the bombing of Warsaw in 1940, for example, the Germans used Ju-52 transport planes as auxiliary bombers. The US started to use C-130 cargo planes to drop Blue 82 Daisy Cutter during the Vietnam War, and continued using the technique in the 1991 Iraq War and in Afghanistan with larger GBU-43B Moab bombs. But those are bombs, not missiles. The planes have to fly much closer to their targets to deploy them than to deploy standoff cruise missiles. The risks are tolerable when the enemy, like the Taliban in Afghanistan for example, has meager air defenses. But when facing off against sophisticated multi-layered defenses like those in and around China, the carpet bombing raids of previous generations often carry unacceptable risks for the aircraft dropping them. Hence the rise of standoff cruise missiles, which can be launched from beyond the range of air defense systems, and even more advanced fighter jets and bombers to launch them. But the problem of limited launch capacity remains. Now, you just can't roll missiles out of the hatch of a transport plane like you can with glide bombs. Nevertheless, the US has been experimenting with ways of launching missiles from cargo planes since Vietnam. In 1974, the US actually demonstrated the feasibility of launching an ICBM from practically anywhere when it test-fired a 57-foot, 88,000-pound LGM-30 Minuteman airdrop from a C-5A Galaxy. The following decade, a lower-cost alternative to the B-1 bomber, known as the Cruise Missile Carrier Aircraft or CMCA, was designed. The idea was to reconfigure Boeing 747-200 cargo airframes as special-purpose cruise missile launchers with a capacity of 50 to 100 AGM-86 ALCM missiles. The missiles would be released rapidly via a rotary launcher on the side of the tail fuselage and dynamically targeted by an onboard control system. The CMCA was never fully developed, but Rapid Dragon builds on the same core idea, adapting existing aircraft into standoff arsenal ships at lower cost. The key concept that made this possible was first explored in 2003 by graduate students at the Air Force Institute of Technology when they deployed missiles from the rear of transport aircraft using parachuted pallet trays. The idea was further fleshed out during the 2010s, culminating in Rapid Dragon. The program debuted in 2019 and was developed further from 2020 to 2021 by a team of US Air Force development groups and industry partners. Initial tests at White Sands Missile Range in New Mexico during 2021 validated the release of representative missiles from both the C-17A and C-130s aircraft. By the end of 2021, the concept was ready for live-fire testing. In its first and final live-fire test over the Gulf of Mexico on December 16, 2021, an armed Rapid Dragon received target data from a distant command and control node in flight on board an MC-130J cargo plane. It then used the data to target its armed AGM-158B Joint Air-to-Surface Standoff Missile, or JASSM missile, was airdropped and successfully deployed its payloads, with a live missile destroying its naval target. Just under a year later, in November 2022, the first European theatre live-fired demonstration of a JASSM airdrop from an MCU-130J in a Rapid Dragon pallet was conducted at Andøya Space Test Range in Norway as part of the Atreus 2022 military exercises. And now, in 2026, the experimentation phase is over, and Rapid Dragon is ready for action. In April 2026, the Air Force Life Cycle Management Center, or AFL-CMC, announced the establishment of Dragon CART, the official program of record to arm mobility aircraft with so-called palletized munitions. That means Rapid Dragon isn't an experiment anymore. It's an official operationalized US military program. This designation is an important step and underscores how serious the US military is about the Rapid Dragon CART project. The project's program of record status guarantees long-term budget allocation and formal integration into future force planning. In May 2026, the program entered the transition phase between experimentation and operational deployment, with fielding expected in 2027 through the middle-tier acquisition rapid fielding pathway. How it works is both technologically advanced and remarkably simple. Rapid Dragon is like a smart and disposable bomb bay in a box that includes an interface allowing targeting information to be fed to the munitions from a distant fire control center. The missiles are loaded into palletized launch modules, which are in turn loaded onto transport aircraft. Loading is done through standard cargo handling systems already widely used across the Air Mobility Command Fleet. After being released from the rear ramp, the pallet stabilizes under a parachute before releasing cruise missiles sequentially in mid-air. Sounds like a relatively simple, low-tech solution, right? In a sense it is. The system uses unmodified standard US military cargo aircraft, and missile deployment requires no additional crew skills beyond those needed for regular airdrops of supplies or vehicles. But let's not downplay the technological and procedural ingenuity that makes it possible. Unlike many legacy defense programs, Dragon CART is structured to maximize government data rights and maintain government control of the technical baseline. According to Kent Muller, the systems engineering program manager and program architect with the Dragon CART program, Dragon CART is literally the born digital dream come true. It's a system that was born inside model-based systems engineering models. Model-based systems engineering, or MBSE, is a methodology that uses formal models rather than documents to define, design, and verify complex systems. It represents a fundamental shift in how engineering organizations capture and communicate system requirements, architecture, and behavior. Instead of relying on documents, MBSE uses integrated machine-readable models as the single source of truth. So, how does that apply to Dragon CART? As Muller explained, because we own the engineering, if a new payload needs a launch module that is slightly longer, we just model it, do the load path analysis, and send that model to our production vendors. So, by assembling proven, existing technologies in novel ways and maintaining strict control over the digital architecture, the program office has eliminated traditional roadblocks, allowing for rapid scaling and future upgrades. What's more, this modular rapid iteration system has already been proven in action. The size of the deployment boxes in tests was configurable, ranging from 4 to 45 AGM-158B JASSM-ER or extended range cruise missiles. But that's far from the only missile that Rapid Dragon CART is intended to deploy. In the long term, according to the AFL-CMC, The program office seeks to streamline the battle space by developing a single, common, air-to-surface munition that's affordable, adaptable, and possesses significant standoff range. Now, the design of that missile should allow for it to be deployable from both palletized and lugged launch configurations. But until that design is finally delivered, the Rapid Dragon Dragon Cart system has been designed to handle a variety of existing cruise missiles and several new ones. The palletized launch system was designed and built by Lockheed Martin to carry and deploy several variants of its self-developed JASSM range. That includes the aforementioned AGM-158B JASSM-ER, a stealthy land attack cruise missile with a range of 575 miles, and its B-2 variant featuring enhanced stealth and electronic warfare resilience. It also includes the AGM-158C LRA-SM, or long-range anti-ship missile, which offers a similar range while carrying a more advanced guidance suite purpose-built for maritime warfare, and the upcoming JASSM XR that has a 1,000-mile range. Yet, as capable as these weapons are, they're also extremely expensive and take a long time to produce. Approximately 3,232 of the B variant of the JASSM-ER are to be produced in total, with orders for the US as well as Japan, the Netherlands, Poland, Finland, and Australia. The unit cost varies depending on the production lot, anywhere from $1 million to $1.6 million per unit. That upper end is also typically what the upgraded B2 variant costs, with a total production of 4,656. The C variant, or LRASM anti-ship missile, is significantly more expensive, thanks to its additional autonomous target recognition, IR/RF seekers, and data links. Unit costs can reach as much as $3.5 million per unit. Since it's still in development, the total production and unit cost of the XR aren't yet clear. But there's a bigger issue than the cost: the production rate. Current production rates across all variants run at between 400 and 500 per year. A new 225,000 square foot production facility was introduced in 2022 to increase production to around 1,000 units per year, thanks to automated processes such as robotic paint lines and advanced testing. The problem is that the US can burn through those rapidly. During the 4 weeks of active bombing as part of Operation Epic Fury against Iran, the US is estimated to have burned through 45% of its precision strike missile stockpile, half of its THAAD interceptors, nearly half of its Patriot PAC-3 air defense missile inventory, roughly 30% of its Tomahawks, and more than 20% of its long-range JASSMs. Those stockpiles would take years to replenish, even at the extended production rates. Pentagon internal assessments are already raising the alarm of a near-term risk of running out of ammunition. If the war in the Persian Gulf flares up again for a considerable period, or the US gets entangled in further conflicts, for example in Taiwan, the problem may become even more acute very quickly. Now, if daily news updates and deep dive analyses on the most important military and geopolitical developments are what you seek, make sure you subscribe to the channel. At The Military Show, you'll find some of the most detailed, accurate, and insightful military content on YouTube. The Rapid Dragon will certainly extend the number of missiles that the US can deploy in quick succession. The F-22 Raptor can carry 8 missiles on air-to-air missions, 6 AIM-120 AMRAAMs and 2 AIM-9 Sidewinders. The F-35 Lightning II carries 4 AIM-120 AMRAAM air-to-air missiles internally while operating in maximum stealth mode. A new sidekick rack will expand the internal total to 6 AMRAAMs, but short-range weapons like the Sidewinder have to be mounted on external wing pylons, which compromises the jet's radar-evading profile. The B-52 Stratofortress can carry up to 20 JASSM cruise missiles, 8 internally and 12 externally, or 24 JASSM-ERs or LRASMs internally. Its external payload capacity is being upgraded to carry even heavier loads. The B-1B Lancer can carry 24 JASSM-ER or LRASM cruise missiles internally, but with new external pylons, its total capacity could increase to 36 missiles. That's a fearsome array of firepower. But here's the rub. Of the JASSM-carrying bombers, the US only has 75 B-52s and 45 or 46 B-1B Lancers in active service. Now, in effect, the Rapid Dragon Dragon Kart project will dramatically increase that total by turning hundreds of cargo transport planes into auxiliary bombers. The US has a massive fleet of cargo planes in service, including 222 C-17A Globemaster IIIs, 151 of the C-130J Super Hercules, 126 of the C-130H Hercules, 57 MC-130Js, and 39 HC-130Js. All of these can conceivably be turned into bombers simply by loading Dragon Kart pallets into the storage bay instead of normal cargo. The US also has 52 C-5M Super Galaxies in service. However, with their remaining service hours diminishing, these are likely to be saved for strategic transport missions rather than used as bombers. These cargo planes could dramatically increase the number of missiles deployable in a single multi-plane mission. A C-130 could launch 12 JASSM cruise missiles from a safe distance of 620 to 1,180 miles from the target with the use of 2 Rapid Dragon pallets. The larger C-17 could accommodate 4 Rapid Dragon pallets, each carrying 9 missiles, for a total payload of 36 missiles with 1,100-pound warheads. But there's no point building all that extra capacity for firing missiles if sufficient quantities of those missiles are not available, and might take years and billions of dollars to replenish. That's why, as mentioned earlier, in the long run, the US intends to develop a single cost-effective, highly scalable missile for use with the Dragon Kart system. In the meantime, it's fast-tracking the development of several other low-cost, highly scalable missile options for use in the pallets. And when it comes to procuring these missiles, the US is certainly putting its money where its mouth is. The Pentagon intends to spend $12 billion to buy nearly 28,000 cheap cruise missiles over the next 5 years to supplement its JASSM procurement, a combination of both lugged and palletized options. The US has several programs underway to develop these low-cost missiles. In terms of the Dragon Kart project, the AFL-CMC specifically identified the Family of Affordable Mass Munitions, or FAM, developed under the Extended Range Attack Munition, or ERAM initiative, as the preferred missile family for future Dragon Kart deployment. In particular, in May 2026, the Pentagon launched the Low-Cost Containerized Missiles, or LCCM program, in conjunction with defense manufacturers Anduril, Co-Aspire, Leidos, and Zone 5. At the same time, it would be working with Castellion to scale low-cost hypersonic solutions. In total, the Pentagon intends to acquire 10,000 missiles across the program within 3 years. That's a mammoth undertaking. But what kind of missiles can we expect to see in the LCCM mix? Anduril has announced that its contribution to the program will be the surface-launched version of its Barracuda 500M missile, a weapon that can also be air-launched. The missile has a stated payload capacity of up to 100 pounds and an expected air-launch maximum range of up to 500 miles. The company says it plans to deliver a minimum of 1,000 of these weapons to the US military in each of the next 3 years. Leidos says it will supply an LCCM design that leverages existing work on its air-launch AGM-190A Small Cruise Missile, SCM, also known as Black Arrow. Originally developed for US Special Operations Command, or SOCOM. The missile carries a roughly 200-pound munition and has achieved a range of more than 400 nautical miles in testing. The company plans to deliver 3,000 of these units under the new framework deal. It's as yet unknown which designs Co-Aspire and Zone 5 will ultimately deliver, but they're likely to be modifications of the missiles already developed by the company for the ERAM program. And that looks like an exciting prospect. Co-Aspire's ERAM design is called the Rapidly Adaptable Affordable Cruise Missile, or RACM. It's a modular, low-cost cruise missile that leverages 3D printing to bring down costs and enable rapid production ramp-up. The ER, or Extended Range variant, reportedly has a range of over 1,000 miles. The Rusty Dagger was ostensibly built for supply to Ukraine, but has subsequently found a domestic home under the ERAM program. It's understood to have a range of between 150 and 280 miles, a payload in the 500-pound class, and a blast fragmentation warhead with at least some degree of penetrating capability. As for the low-cost scaling of hypersonic options mentioned in the budget proposal, Castellion manufactures the lower-cost hypersonic Blackbeard missile. Not too many of the exact specifications have been revealed, but we can derive some of them from official records. According to the Army's proposed budget for the 2026 fiscal year, the goal of Blackbird GL, or ground-launched, is to deliver approximately 80% of the Precision Strike Missile Increment 4 capability at a significantly reduced cost. Increment 4 seeks to increase the PRSM's range from 310 miles to 620 miles. So 80% of that capability would give Blackbird a range of around 500 miles. It's unclear what kind of payload it will pack. Boeing's new JDAM LR cruise missile and its maritime strike variant also look like suitable options for use with the Rapid Dragon system. Both can deliver 500-pound warheads to targets 375 miles away. Now, the Dragon Cart system clearly opens up a new way for the US to greatly increase the number of cruise missiles it can deploy by greatly increasing the number of planes from which it can deploy them. But it also has strategic implications, especially for a near-peer rival like China. That's somewhat ironic since the name Rapid Dragon has a Chinese origin. It's derived from a 10th century Chinese volley-firing siege weapon known as the Jilongche, or Rapid Dragon Cart. This was a kind of crossbow that could simultaneously launch large numbers of long-range crossbow missiles from a safe distance. Similarly, the present-day Rapid Dragon launch system is intended to saturate an enemy's defenses from standoff weapon distances, where the launching aircraft is not threatened. It can be rapidly fielded, using existing fleets of airlift assets to offer the option of significant surges in mass attack missions at minimal cost and training. But in addition to offering more bombers more rapidly, Dragon Cart also allows the US a much greater variety in a multi-pronged attack. The US can now combine pallets of low-cost cruise missiles with higher-end JASSM-ERs and LRASMs. The less expensive weapons could help saturate enemy airspace, while the stealthy JASSM-ERs and LRASMs hunt for more lucrative targets. The use of cargo planes already introduces ambiguity into adversary targeting calculations. Are those relatively harmless C-17s carrying supplies to US troops stationed in the area? Or are they ready to open the hatch and unleash dozens of precision cruise missiles? Chinese operational planners can't be quite sure about what the planes are doing and what missiles they might be launching. When combined with secure data links and network targeting architectures, Dragon Cart also supports the distributed warfare concepts increasingly central to US operational planning. By dispersing long-range fires across mobility aircraft fleets, rather than concentrating them on a limited number of bombers or tactical fighters, the US increases its offensive scope while greatly complicating defense against them. That's a serious monkey wrench in the plans of the painstakingly and expensively constructed Chinese anti-access and aerial denial networks, designed to complicate US air operations across the Indo-Pacific. By dispersing strike capability across cargo aircraft fleets, Washington complicates Chinese planning while preserving operational endurance during prolonged campaigns. But perhaps most importantly, the Dragon Cart pallets don't require any modifications to the launching aircraft, so there will be no modification costs for America's cargo fleet. That also means that Dragon Carts can be provided to allies or partners in any of the 63 other countries that operate C-130s, making the system a very inexpensive way to provide standoff strike capabilities to partner forces as well. All in all, it's an innovative and pragmatic system that keeps the US a step or two ahead of any of its rivals or allies. We'll of course keep a close eye on development and keep you updated. It's certainly not the only US military development that's keeping Chinese President Xi Jinping up at night. Check out this video to see why China's prized aircraft carriers would lose to a 1970s US warship. And thanks for watching.